In this video, we're going to take a look at some examples of finding the slope of a line with the formula for slope. That formula looks like this. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where you have 2 points. Point 1 would be x sub 1, y sub 1. And point 2 would be x sub 2, y sub 2. Now the slope of a line is constant, which means that it does not matter which 2 points you choose to plug into the slope formula, you will always get the same slope. Let's give this formula a try with a couple of points that we are just going to pick. Point 1 we're going to let be 1, 2. And point 2, I'm going to let that be 0, 3. Okay? If we plotted these 2 points on a graph, let's just take a look at what that might look like, just to kind of see what it is we're finding. I don't have a nice grid behind me, so this is not going to be the perfect line ever, but it'll look okay. To plot the point 1, 2, I need to be 1 over on the x and 2 up on the y. So that point would be about right there. And then to plot the point 0, 3, I'll need to be at 0 on the x, which is right along the y-axis, and I'll need to go up 3 units. That might be a little bit high. Then we would connect those 2 dots and draw a little bit beyond both of them to get our line. Okay. Actually, that might have been better if I had drawn it with a line tool, but I think it'll be all right. Anyway, you get the general sense of the idea. We've got a line here between these 2 points. Now, to find the slope of that line, what we do is we take the formula that we wrote down just a second ago, and we plug these 2 points into that formula. I'm going to let this point be x1, y1, okay? And then my second point, 0, 3, is going to be my x sub 2, y sub 2, okay? So I've got the difference in y sub 2 and y sub 1 as the numerator of my slope. That's the change in y, or the change in the vertical distance between those points. So if we were to just walk it off over here on the graph, we would be moving up from this point to here. So we would be moving up 1 unit, okay? So that we've got 3 minus 2. And as you can tell, that's going to come out to be that 1 unit that we get if we just walk up the slope. That's our rise. And then our run is x sub 2 minus x sub 1, 0 minus 1. And if you look at the run over here, you can see that that's also just 1 unit. Okay, that's the horizontal distance between the 2 points. So we're going to have a 1 in the denominator as well. A negative 1 in the denominator, actually, because we are going to the left, okay? So we have a positive 1 in the numerator, we have a negative 1 in the denominator, and that gives us a negative 1 as our slope. Negative slopes do decrease, okay? Positive slopes will increase. They go up as the line goes to the right. Let's try a couple more points in that same equation, just to get a better sense of what we're doing. 7, negative 2, and 3, 4. Now what you want to do at this point is just pause the video for just a second and plug those values into the formula that I've given you, work through it, and then turn your video back on so you can see how you've done, okay? All right, let's plug in our values. If I let this be x sub 1 and y sub 1, x sub 2, y sub 2. And as I may have mentioned, it really actually doesn't matter which point you let be which, okay? If I want 3, 4 to be my x sub 1, y sub 1, that's fine, okay? It will not matter which 2 points you pick, the slope is constant, so any 2 points on the line will give you the exact same slope. All right, so my y sub 2 is 4, my y sub 1 is negative 2, so that becomes 4 plus 2, because remember we're getting the difference when you've got a negative that we're subtracting, so it turns into a plus. And then x sub 2 is 3, and x sub 1 is 7. So we've got 3 minus 7 on the bottom. Looks like we're going to wind up with another negative slope. So on top, we get a 6, and on the bottom, I get a negative 4. You want to reduce it as much as you can, but you do not want a decimal, and you don't want a mixed number, because when we use slope, we typically want that fraction form that gives us that rise over the run, okay? So we would have a negative 3 halves after we've reduced it for our slope. All right, let's try one more time. Maybe 10, 6, and negative 2, negative 3. Okay, and again, it might be a good idea to stop the video now and work that out on your own, and then come back to it in a minute when you're done. Okay, let's plug in. And again, it doesn't really matter which one you've called x1, y1, and x2, y2. That's why I'm going to label it there. And so I've got negative 3 minus 6 over negative 2 minus 10. Okay. And that's going to give me negative 9 over negative 12. Got two negatives. That makes it a positive. The negatives divide out. And then I've got 9/12, which will reduce to 3/4 for my slope there. Okay.